Alright, welcome everyone to the next lesson in this series, and in this video we will look at Calico and BGP for Kubernetes. Now, we've explored certain networking constructs in Kubernetes such as pod IP ranges, service side ranges, and these IPs are typically routable only within the cluster, as in they can be only accessed by workloads inside the cluster. Now, when you want clients external to the cluster to access certain services internal to the cluster, we typically configure what is known as a load balancer type service. Now, we've not explored the load balancer type service yet. However, in the case you configure such a service, you would need something like a border gateway protocol to peer with your upstream network and advertise these IPs to the upstream network so that you can steer inbound traffic towards the cluster. So in this lesson, let's look at how you can configure BGP with Calico in a Kubernetes cluster. So let's get started. Okay, so if you've cloned this repo, this lab can be found in the container lab calico-bgp folder. And in my case, I've already gone ahead and deployed this lab. You can deploy the lab by executing the deploy script. So let's go ahead and inspect the lab topology here. The output on the right is a bit verbose. So let me look at the output in the lab guide here. So we have a 3-node kind cluster. This lab is very similar to the lab we deployed previously in the overlay lesson. So we have the kind cluster and we rely on the ext-container to add additional interfaces to the nodes in this kind cluster. And we also have an Arista CEOS image. So let me go into this diagram. We have a lab topology. So we have the management network, which is the network that will be deployed by kind. And in addition to that network, we create VLAN 10, the VLAN 10 network segment. And in each of the nodes, we create ETH1 as an additional interface and bind that to VLAN 10. And the default gateway for VLAN 10 is configured in this router, which is the CEOS image. And this has an IP of 10.10.10.1 for VLAN 10. Okay. So if you, let me clear this. And if we look at the lab topology here, just give me one sec. So in the lab topology, we can see how the links are created between these interfaces. And for the kind nodes, we see the additional interfaces that are added in VLAN 10. Okay. So this is the base topology, and we will use this topology to create BGP peer rings from these nodes towards the router. Okay. All right, so let's go back to the lab guide here. So make sure you've exported the kubeconfig file that the script spits out once it has deployed the lab. And once you've exported the kubeconfig file, you could do a kubectl get nodes. As you can see, we have a 3-node kind cluster here. And we looked at the topology file, and in the topology file, we saw the additional interfaces as well as the IPs that were configured. So the control plane node has IP of 10.10, worker 1 10.11, and worker 2 10.12. And this is how the links are configured with the CEOS router. So control plane ETH1 goes to CEOS ETH1, worker ETH1 to CEOS ETH2, and worker 2 ETH1 to CEOS ETH3. Okay, so this is the topology once again there. All right, so in addition to some of the initial deploy scripts for this lab, if you go to the Calico CNI config folder over here, and if you look at the manifests in that folder, we have a couple of additional manifests for BGP configuration and BGP peer. Okay, so if I do a cat on the BGP configuration manifest, this configures BGP in Calico. All right, so essentially in this case, we are specifying an autonomous system number, which is 65010 for Calico, and a node-to-node mesh enable false. In this case, what it means is that we are not using BGP between the nodes in the cluster. In the previous lesson, when we looked at overlay networks, we were leveraging VXLAN as an overlay. However, we also discussed that you have the option of leveraging IP-IP as an overlay. And when you leverage or use IP-IP, Calico uses BGP inside the cluster to propagate routes, right? We don't need it in this case, and that's why this flag is turned off. So this manifest essentially configures an autonomous system number for Calico and turns on BGP and the bird daemon, which is the daemon that runs in the Calico pod in every node in the cluster. Okay. All right. So in addition to that BGP configuration manifest, we also have another one called BGP peer. And you can have a BGP peer resource for every upstream peer that you configure. In our case, we're going to be configuring a single BGP peer, which is this router over here. And the router has an IP address of 10.10.10.1. So you see the BGP peer configured as 10.10.10.1. And this router has an autonomous system of 65001, which is the remote peer's AS number. And node select all in this case means that we will create a peering from all the nodes towards this router, right? And as indicated by this parameter, you can be selective by specifying which nodes would peer to a given upstream router. But in this case, we are peering all the nodes to this particular router. Okay. All right. So let me clear that and go back to the previous folder. So we looked at the BGP configuration resource as well as the BGP peer resource in Calico. Okay. So next, let's look at the configuration in the router. So in the lab folder, there is a folder called startup configs, and the startup config folder has the startup configuration for the CEOS image. So if I cat that output, we see the BGP configuration in the CEOS image, right? In that Arista image. So this one has a BGP AS of 6500. There is a router ID. And what we've done here is we've configured what is known as a BGP peer group. So as far as the router is concerned, it's going to be receiving BGP peer requests from IPs in this subnet, the 10.10.10.0.24 subnet, right? So essentially we've configured 10.10.10.0.24 as a listen range for this router, right? So instead of configuring individual peers, which we could have done, we've specified a range, and for that particular range, we've specified certain parameters. The most important one being the remote AS. So if you remember the Calico BGP configuration, the autonomous system was configured as 65010. And in the CEOS's image, we've specified that the remote AS as 65010, and the AS has to match for the peering to be successful. Alrighty, so let's move back to the lab folder. Now, once the configurations are in place, what we can do is you can execute a Calico Cuttle get BGP peers, and this is going to spit out the existing active BGP peer configurations, right? And if you want to validate whether the peering is successful, there are ways to do it in Calico as well. But for this lab, I am going to exec into the CEOS image. And once you're in the router, you could do a show IP BGP summary. And this output here indicates that there are 3 BGP peers from the perspective of the router. All right, so if I expand this diagram over here, so from the perspective of the router, we have 3 BGP peers. Let me expand the output here. And these are the peer IPs. So 10 is the control plane node, 11 here is worker 1, and 12 is worker 2. These are the remote ASs of those BGP peers, right? And the status here is established, which means the BGP peering is successful. So it's important that this be established, right? In terms of prefixes, it's all 0 because although we have the peering established, we are not advertising any prefixes yet. We will look at advertising some prefixes in the subsequent lessons, okay? All right, so to summarize this, in Calico, we had the BGP configuration resource, which basically activates BGP in the Calico node daemon set, which is a pod deployed in every node in the cluster, right? So we activate BGP over here and provide it an autonomous system number of 65010. Next, in Calico, we configure a BGP peer resource. And in this case, our PIP is 10.10.10.1, the IP over here. And we specify the remote AS of the Arista router, which was 65001, as observed by the configuration in the router as well. And we initiate a peering from all the nodes in the cluster. So from the perspective of the router, we provide the reciprocal configuration to the Calico side, right? And the result of it is that we now have a BGP peer from each of the Calico daemon sets, Calico pods, towards the router, okay? So if I go back, let me exit from this, and if I do a kubectl get pods dash in Calico hyphen system, right? So what you're going to notice, let me do a dash O wide on this output. So what you're going to notice is in every node, there's a Calico node, right? And the BGP daemon, which is a daemon called bird, runs inside this Calico node, right? So if we go back to that diagram, this Calico image here is basically indicative of that Calico node pod that we see deployed as a daemon set in every node in the cluster. Now, in subsequent lessons, we will dive a bit deep into the BGP daemon, how you could execute some commands inside the daemon to validate the BGP config, the status, as well as troubleshoot peering issues, right? We'll do that in a subsequent lesson, okay? In this lesson, the objective is to show you how BGP peering can be established from Calico to an upstream router, okay? All right, so with that done, that's the end of this lab. So in this lab, we've successfully configured BGP peering from the Kubernetes cluster from Calico towards an upstream route. And in the subsequent lessons, let's look at how you can leverage this BGP peer to advertise certain IPs to your upstream network to steer traffic towards the cluster. So I'll see you then. Bye for now, and thanks for watching. See you in the next one.